Hello, good day, viewers. Negative 3 to the power of 2. Negative 3 to the power of 2 has been trending this week. Some people were saying that it must be 9, while others are saying it must strictly be negative 9. So before I reveal my own answer, let me remind you two things. One is part of the laws of indices, and secondly, we are going to jump into quadratic functions or equations. All right. Remember, in one of the laws of indices under distributive property of exponents, if I have x multiplied by y raised to the power of n, you should know that this power of n is only affecting y, not x, according to one of the laws of indices. But if I have x multiplied by y raised to the power of n, this exponent of n must be distributed upon x and y. So this is equal to x raised to the power of n multiplied by y raised to the power of n. This is a law of indices, remember. And if we have in quadratic equation, remember we can have x squared plus 5x plus 6 equal to 0. This is a quadratic equation where the leading coefficient is 1. So what if we have 2x squared plus 5x plus 6? Isn't this a quadratic equation? Of course it is. And you should know that in algebra, we use letters to represent numbers, which implies that x is also a number. It is representing a particular number in this equation. And we know that this power of 2 is only affecting x, because we cannot say that after simplifying this, we must get 4x squared. This is wrong. The power of 2 is only affecting x. And we may have a quadratic equation in this form, negative x squared minus 3x plus 5, for example. X's are representing numbers here. And we know that this power of 2 is only affecting x, not with negative x. But what if we have negative x raised to the power of 2 minus 3x plus 5 equals 0? This time around, both the negative and x are going to be affected by the power of 2 according to this law of indices. Because if you have multiple terms, though I cannot call them terms because they are together, multiple variables multiplying each other or one another raised to the power of a certain exponent, that exponent must be distributed upon all the variables under that parenthesis. So we have a parenthesis here, which is negative x, but raised on to the power of 2. This implies that this power of 2 must be affected on negative and x at the same time. So if we should simplify this, it is going to become, negative 1. Negative x is the same thing as negative 1 multiplied by x, mathematically speaking. So if we raise this to the power of 2 and raise this to the power of 2, negative 1 squared is 1, x squared is x. This implies that this must be x squared minus 3x plus 5 equal to 0. So let's come back to our main expression. If you should look at this 3 as x, it means that power of 2 is going to affect only 3, not with negative 1. Because, let me write something here. I can write negative 3 to the power of 2 as negative 1 multiplied by 3 to the power of 2. They are all exactly the same. And you can see that power of 2 is only affecting 3. And 3 squared is 9. We have negative 1 multiplied by 9, which is equal to, indeed, negative 9. Some people were saying that, let me write it here. We are done with this one. What if we have negative 3 squared, but with a bracket or parenthesis like this? You should know that this parenthesis is useless because It's only when you have a value outside parenthesis that it will affect everything inside that parenthesis. So we don't have anything. We don't have any number. We don't have any exponent. So this parenthesis is useless, please. We don't have anything like this. But suppose we have negative 3 raised to the power of 2. You can see that we have a parenthesis, but this 2 is outside the parenthesis, which implies that it is going to affect everything in that parenthesis, both the negative and the 3. And I told you that negative 3 is the same thing as negative 1 multiplied by 3. But since they have a power of 2, applying that law of distribution of exponent and laws of indices, we can say that this is negative 1 to the power of 2 multiplied by 3 also to the power of 2. Negative 1 to the power of 2 is 1 times 3 to the power of 2 is 9. In the end, we have 9. So when you have negative 3, then power of 2 outside, it must be what? Negative 3 times negative 3, which is positive 9. But when you have something just like this, you should not consider this as negative 3 to the power of 2. Negative 3 together, just like this one. They are not the same. But this one and this one, they mean the same thing because this parenthesis is useless here. It has no any effect on this negative 3 to the power of 2. I repeat, negative 3 to the power of 2 is equal to 9 negative. Is equal to negative 9. That is what we call, I think we are misinterpreting this. When we say negative 3 to the power of 2, you cannot call this one negative 3 to the power of 2. This is not negative 3 to the power of 2, but this is negative 3 to the power of 2. Some people might say, wow, how? Okay, in mathematics, when you have a parenthesis to a certain power, for example, if I say x plus 2 to the power of 3, we don't call this x plus 2 to the power of 3. When you say x plus 2 to the power of 3, this is what you are saying. X plus 2 to the power of 3. This is what you are saying. But we call this x plus 2 whole to the power of 3. Whole, everything to the power of 3. X plus 2 whole to the power of 3. But this is x plus 2 to the power of 3. You see the difference? So this is minus 3 to the power of 2. But this is minus 3 whole to the power of 2. That is just the difference between them. So let me make a conclusion here that negative 3 to the power of 2 is negative 9, not positive 9. I repeat, not positive 9. Bye-bye.